Folks, this lesson is called Expanding Quadratic Functions. And I should warn you that some people find this the very hard part of the chapter. Okay? And I don't mean that to scare you. I mean that to say, maybe you better listen to this. Because I have several ways to teach it. And the people who listen eventually go, oh, I can do this. Yeah, if you do listen, it's not really a problem. It's when you don't pay attention to this. I just went through this in 11U today. They wrote a quiz, and there was 2 students who weren't paying attention, and their quiz was blank. They didn't even know anything about how to do any of the math because they hadn't been listening. But if you do listen, it's okay. It's not that bad. Okay? So, I know we say that as teachers all the time, like, oh, pay attention. I might even got a little snarky about it yesterday, getting some people to pay attention. It's because I'm getting worried about this particular stuff right here. Well, the last 2 lessons, not too bad, but this one, we really want to zone in here. So I've got the fancy learning goals here. Today we'll learn that there are 3 different ways to write quadratics. Quadratics can appear and look 3 different ways, and we'll learn how to change between 2 different ways.
Do you need the graphic down?
Yeah. Some good writing coming up. So get a pencil ready. But again, I printed this all out for you, so you only have to write the stuff that's really, really important to you. Okay? So when you're writing, you should be thinking as well. We will be successful today if we can change an equation from factored form to standard form. It is okay at this point if you're like, I don't even know what factored form is. I don't know what standard form is. But this is how we'll judge our success at the end of the lesson. If we'll know what factored form is, we'll know what standard form is, and we know how to switch between the 2 of them. All right. I got mine here so that I can say the right things at the right times. Throughout this course, we will see the equations of quadratic functions appear in 3 different forms. It's okay if the forms look weird right now, but here they are. So you can look back at them and see. Standard form will look like this. Y equals 2x squared plus 16x plus 30. You've got to write that down on purpose. I carefully chose the times you would have to write things down to go, oh, we better learn how to write out standard form. Now, standard form has no brackets. No brackets. That's the way you can tell it's in standard form because you won't see any brackets. You'll just see x squared terms and numbers. Some people think it's the simplest way to write quadratics. I don't know if it is. But it's the simplest looking because there's no brackets to try and figure out what's happening. Now, the next form is called factored form. And it looks like that. This is the same equation in factored form. Somebody really clever has converted this from the first version to the second version. We don't have to do that yet. Okay? But I'm just telling you, those 2 things are the same thing. I'm going to write that on there. I got to do PowerPoint writing, which is a little bit awkward, so just give me a second. Pointer options, pen, and that color is going to be no good. I want you to add one little thing to yours. I'll switch to yellow so you can see. And I'm just going to write something, a little arrow, and say, same quadratic. That's the same one. And you're like, how can that possibly be the same one? Well, that's why you're paying me to be here, is I'm going to explain how that's the same one. We only have to do one version of this today, switching from one version to the other. But you could write this like this. It'll be the same thing. It'll give the same answers. If there was an equation for a home run, it would give the same distance for the home run. All that stuff, okay? Those are the same. If you wrote it down, if you copied it down correctly. Just seeing if Mr. Jastrzewski has a controller. I'd really like a controller, but I don't have a controller. Oh, he does have a controller. Is this going to work? No. It's not working. Oh, it should be working. I'll try it out and see if it does work. Maybe it needs a battery. All right. Last version. We also might see these in something called vertex form. And it's okay if right now you're like, I don't know why this is called vertex form. Maybe I do sort of remember the word vertex from your other lesson, though. I'm not sure if I remember right now. what a vertex is. And that's all okay right now. I'm just introducing this and saying this is the same. And then I'm going to switch over to my fancy pen again and add one more thing. Don't worry. This is also the same quadratic. And if you're curious, you should be like, well, if they're the same, how do I change or convert from one to the other? And again, that's why I'm here today, is to show you how to convert. I'm going to do the easiest conversion. I'll show you in a minute which one it is. Pointer options, turn the pen off. Okay. I wish this controller was working. All right, all right. Are you caught up? Okay. How are we going to tell long term? Let me give you a little hint. Standard form is not going to have any brackets. Vertex form has only one bracket. Factored form has two brackets. There are some special cases, but that's good enough for now. That's the idea, is what you'll see there. The above equations all represent the same function. That's what I wrote in yellow over there, but it says at the bottom there. Okay. Here they are again. Standard form, same equations. Standard form, factored form, vertex form. Do I have to write them all again? Yes, please do. I want you to get used to writing the x's and writing the brackets neatly and how to write this out. And maybe, just maybe, by writing it again, you start to memorize the three different forms. Maybe. Oh, starting to work maybe. Maybe not. Oh, it is working. I fixed the controller. You don't care, do you? Just making my life easier up here. His battery's dead. I'll get him a new battery. Okay. Did you copy those down? Yeah. And it says some things after that. Here's the parts I want to tell you about. Each of these three forms gives important information about the function. The preferred form will depend on the problem. So you're like, well, which form should I use? It depends on the problem. Yeah? I'll give you one hint, though. Which one do you think is best if I want the vertex? Vertex form. Okay, so I've already given away one of the three. It's going to take a little work to figure out why I would want the other two. Okay? In this unit, we will be concentrating on standard and factored form. Vertex form, actually, my grade 11s are working on vertex form right now. It's out there, but we'll mostly work on standard and factored. Okay? In this lesson, we'll focus on switching from factored form to standard form. We're not going to do a lot of stuff. We're just going to go, how do I get from factored form over to standard form? To do this, we use a process called expanding. Example. Now, you've seen some expanding before. It's just distribution. However, the distribution was a little bit easier because there was only one thing out front. Like this, x times x plus 4. Does this ring a bell? When there's something out in front of the brackets here, what did I usually write with this? I think I even offered a mark. 1. Do you remember this? It's a little bit like that high-fiving we were doing yesterday. X has to high five with both of the terms that are inside. X has to high five with x, and x has to high five with 4. And by high five, we mean multiply. So when I want to multiply, oh, look at the PowerPoint does the arrows too. All right, let's talk about this for a second. X times x is x squared. That's really big for us to know that x times x is x squared. And then x times 4 is 4x. We're going to see a lot of this, a lot of the x squareds and the 4x's and the 3x and the 2x and all these things that happen. Here's another one, expanding. Oh, by the way, that's already showing you how to get from factored form, this is called factored form because it's got brackets, over to expanded form. Here's another one, factored form into expanded form. Again, we do the arrows. Yeah? It's just like the high five thing. Negative 3x has to high five with 2x, but it's also got a high five with a negative 5. Both of those things. It's got to multiply by both of the things in the brackets. Now, this is the moment some people have trouble with. Right here. This is where the algebra gets a little tough. Lots of people write the arrows. What's negative 3x times 2x? 6, I like. Hopefully most of you like 6. But it's negative 3 times 2, so instead of positive 6, negative 6. And I encourage you to expand these that way. First, think about the numbers. What are the numbers? Negative 3 times 2, that's negative 6. Then I also have an x times x. What's x times x? What's x times x? X squared. So if I'm doing negative 3x times 2x, I do get the negative 6, but I also get x squared. The second one's usually easier. Negative 3x times negative 5. What's negative 3 times negative 5? It's there on the screen. Positive 15. You're like, oh, this is the part I have trouble with. Well, that's what the calculator's for, maybe. But negative times negative is positive. We're already doing what I said I was going to do today. Going from factored to standard form. Just multiplying out the brackets. That's pretty much what we're going to do today. But I'm going to show you some other weapons on how to do it. Any questions there? Do you need more time? Yes? Why are we 7 people short today? Is there a trip, sport, something going on? Oh, many people writing literacy today. Okay, good. Oh, and tomorrow's Remembrance Day services, okay? Remind me to talk about that at the end. Just because you got to be dressed up tomorrow. Of all days, you know? You can play around with liturgies if you want, but don't play around with Remembrance Day. Tomorrow's Remembrance Day liturgy. Yeah? Yeah. So get the good stuff out for this. You know, all right. Anyways. Oh, wait. Who needed more time? Still more time? Are you good? Just the bottom one. Okay, that's fine. I'm not rushing you. I don't want to bore you either. Austin, we're a couple slides ahead of you, but maybe you want to catch up to this slide. Or have you found it already? Oh, yeah. Did yours already have the arrows in it?
Yeah.
I didn't erase them. I tried to erase all the stuff that had to go, but. All right, now, this is the one. This is the one that I think scares people. And I'm going to teach it a bunch of different ways. But somehow, some way, we have to get this down pat, what has to happen here. It's x plus 2 in one bracket and x plus 7 in the other. Let's think of it this way to get started. Let's say x and 2 are on one team. They're in one set of brackets. And x plus 7 are on the other team. And everybody on your team has to shake hands with everybody on their team. Maybe it's at the start of a game. Or maybe it's at the end of a game, and they're all shaking hands. So everybody's got to shake hands with everybody on the other team. That's in the way now. Let me just move that up. So to expand it, we use something called FOIL. This is the first of the ways I'll teach how to do this, called FOIL. And FOIL is just a way of remembering what things have to get multiplied together. The first terms have to get multiplied together, so that's the x and the x. The outside terms have to get multiplied together, x and 7. The inside terms have to get multiplied together, 2 times x. And the last terms, 2 and 7, have to get multiplied together. You can remember FOIL. Some people do. They just use FOIL. Some people just use the arrows. So I've already given you 2 choices of how to do it. Here, I'm doing it both at the same time. Some people will go x times x. x squared. Some people will go, oh, in FOIL. The first ones, x and x. See, there's two ways to remember it, either the arrows or the F in FOIL. I want to slow this down. I'm going to write it, and then it'll appear on the PowerPoint. If I was doing this myself, I would do it like this. X times x, I'd go, oh, that's x squared. Then I'd draw the arrow from the x to the 7 and go, okay, this x has to get multiplied by this 7, and I get 7x. Now the insides, those two, and I get 2x. And now the last 2 times 7 is 14. And that's what the PowerPoint shows next, is x squared plus 7x plus 2x plus 14. Everything in the first bracket multiplied by everything in the second. If you sort of get that, we're pretty much done the lesson. That's all I'm really teaching today. But I'm going to show different ways to do it, because it's hard to remember to do all that. And it's a little bit awkward, especially if you're having trouble knowing that x times x is x squared or x times 7 is 7x. Now, most FOIL questions, I'll start calling them FOIL questions, have an extra step at the end. You get x squared plus 7x plus 2x plus 14. This 7x and this 2x can combine together. I've got 7 x's and 2 x's. I can put those together to make x squared plus 9x plus 14. And again, if that's like, I sort of get it, then we're going to be in great shape. If you're like, I don't know if I really get this, well, I'm going to redo and redo and redo those the rest of the day, showing other ways to handle it. So don't panic yet. Don't do that thing where you go, oh, I give up. I don't get it. I don't know how to do these. Just hold on. Give me a chance to show it a couple different ways. Having said that, do you have any questions? In the box, there's a little box there. Oh, it's too dark, is it? Did I photocopy the box too dark? Eee. You have to write it beside the box. Sorry. In standard form, we write the x squared term first, then the x term, then the constant. Is that like a math rule to be uptight and cause you troubles? No. But what we're going to do next, if we have to go the other way, we're going to want it written this way. So that's just a guide to you. It's going to help if you write the x squared term first, then the x term, then what's called the constant term. And by constant, we mean it's not a variable. It doesn't have a number in it. It's always the same, or it doesn't have a variable in it. It's always just a number. Okay, hold on, Mr. Todd. If there's 2 brackets, each with 2 things in it, then I've either got to use the arrows to multiply it out, or I can use this word FOIL to remember which ones have to get multiplied. Right. That's all I've really done so far, I think. Apparently, we really care about that. Do you have any questions? Do you need more time? No? Right. Note the order of FOIL actually doesn't matter. You could do it in a different order. The reason someone chose FOIL is because that becomes a word. If I had to change it to OILF, it would be OILF or LOIF. Like, I don't know what other words I can make. But FOIL's catchy, right? It's like foil. Oh, I foil it out. That's why it's like that. Okay, another way to think about it. We could also use, did it skip a slide? You got a little van slide, don't you? Yeah. Mine's, is it after? Yeah. Oh, maybe it photocopied wrong. We're going to jump a slide, okay? We'll come back. Oh, it photocopied out of order. That's my fault. We'll jump ahead to this and we'll come back to the, no, I'll jump ahead here. I'll follow yours. Hang on. I know what to do. There was here. Here. Oh no, the van isn't showing on mine. I deleted. The van slide is gone. I love the van slide. Hold on. Let me find out what's happened here. Let me look at my files and figure out what's happened here. Well, that's annoying.
Is that math helpful work?
What's that?
On the wall.
Oh, it's there.
Is that math help work? Last time I tried to go to math help room, it was like completely full and it was only Mr. Yak. Yeah, no, but there was no seats. I couldn't sit. And Mr. Tom was in the house, right? Yeah, I'd rather have a couple good friends than a bunch of. That's basically what Peter has. Peter, yeah. He has too much like that. No, I'm saying he doesn't.
Ah, I think I fixed it. Okay, now we get the van. Is it right now? Oh, I fixed it. Alternative way of thinking about FOIL. Okay, think about this silly example. Ready? Imagine in one van is X and 2. And in the other van is X and 7. And everybody in this van is going to high five with everybody in that van. That's a perfect analogy. Because the X handshakes with this X, the X handshakes with this 7. And this 2 handshakes with the X and the 7. All of that is a perfect analogy. It's a perfect way to think about it. You don't have to think about it that way, but it's a nice way to think about why there's so many arrows going on here. Yeah, that should be lower. That was just the X plus 2, X plus 7. This should be lower. You can just see it underneath the title there. So there's something wrong with that slide. I'll go back and fix that slide. X plus 2, X plus 7. Can I back up enough that you see it? Now, if algebra really isn't your thing, and keeping track of all this is too much, I offer another method. Oh, that's the steps at the bottom there. That's the other way to do that, but you have that on your previous page. You don't need to write that again. Very popular is the box or window method of doing this. It helps people who have trouble with algebra. Here's what they do for X plus 2, X plus 7. They make a big window like this. Do you have your window on the side there? It's got 4 spots. The way they do it is they go like this. Write one bracket along the top and the other one along the left. What I mean by that is there's X plus 2. I'll put it along the top. And along the side, I'll put X plus 7. This is very clever. It makes it so you don't have much to remember. You don't have to remember all the arrows. You don't get messed up by all the algebra. You just do each of the boxes. So look at the first box is X times X. And X times X is X squared. And you can fill it right in the box there. Visual people love this. They're like, oh, I can see exactly what's happening. In this box, X times 2, which is 2X. You see, you just look at the left and look at the top and get 2X. How about this one? This bottom left box, what would be in there? 7X. See? Some people really like this. And what's in this box here? 7 times 2. 14. You see, it's very visual. It's sort of fun. You just fill those in. It's doing the exact same thing I was doing. It's just writing it another way. And then you just write your answer at the bottom. You go, okay, in the boxes is X squared plus 7X plus 2X plus 14. And I can combine the X's. And I got the same thing I did on the previous one. Okay, Mr. Todd, let me just put this in my brain then. When I need to expand like that, I could FOIL. I could do the arrows, or I could do the box. The answer is yes to that. Does it matter which one I do? In grade 10, no, it doesn't. It's not going to hold you back. All 3 of these methods are perfectly good for handling this. So at the start, if I scared you a little bit, saying some people find this tough, only if they didn't pay attention. As long as you paid attention and picked one of the methods, you'll be fine. Do you need more time there? Sorry. More time? Is it good? All right. Here, let's do this one. I'm going to show both ways. So watch both ways, And don't make a decision yet, but start thinking about how you might like to do them. First, I'm going to go, okay, let's do it with the arrows. With the arrows, I would go 3x times 4x. Now, we're just going to pause for a second because this might where you might get into trouble. 3x times 4x. What's the number part going to be? What's the coefficient part going to be if it's 3 times 4? What's 3 times 4? $12. And then I have x times x, which is x squared. This PowerPoint doesn't write them out, so I'm going to write them out over here as we go. I know I'm in the way. $12x squared is the first one. Then 3x times 3. What's 3 times 3? 9. Then negative 5 times 4. See, all the arrows just match up there. Negative 5 times 4 is negative 20x. And then last one, negative 5 times 3, negative 15. And then the PowerPoint shows that. I wish it showed it one at a time. I got to fix those animations. One combining part you can do. The 9x and the subtract 20x. What's 9 minus 20? If it's 9 degrees out, negative 11. But again, you can use your calculator for that if you really want to. But 9 minus 20, if it's 9 degrees out and it goes down 20 degrees, well, it goes down 9 to get to 0, and then 11 more to get to negative 11. That's it. Like, folks, that's all I'm really teaching today. I mean, I've one that's one step harder, but that's pretty much it. Do you have any questions there? Shh. Don't get chatty on me. I'm almost home. Do you need more time? I don't like that way. I like the box way. Can we do the same one with the box? Okay, here it is, the same thing with the box. Go ahead and like the box. It's not better or worse. The arrows in higher grades could be a little faster, but we don't care about speed here. We care about getting the right answers. Shamar?
I don't like using this method.
No, you don't have to. You should copy it down just once, but the whole time you can be copying it down with a sneer on your face like, I don't like this. Same with the arrows. If you're like, I don't really like the arrows, I think I'm going to do box, or window, it's sometimes called. That's fine. You can sneer at the arrows the whole time. Don't get too snotty just yet, because you might find that at some point you might want to switch from one method to the other. With the box method, once you line them up on the sides, you just fill in the individual boxes. 4x times 3x is 12x squared. Visual people will like this. They can just look at it and know what work they have to do, right? 4x times negative 5 is negative 20x. 3 times 3x is 9x. And 3 times negative 5 is negative 15. See, exact same things that were on the previous page. It's just organized differently. Visual people will like this. In fact, visual people will love this. They might, even if they hated algebra up till now, they might look at this and go, okay, well, if algebra is more like this all the time, I guess I could live with it. There is still the one adding up step, though, because you've got 9x and negative 20x. Those are the same type of things, so they can be added together. 9 minus 20 is negative 11. I believe, I've lost count because of the blank parts, but I believe I have 3 more to do. And then just a funny joke at the end. Well, the joke is kind of funny. Sort of funny. This much funny. It's like, no, it's right from a child's test somewhere along the way. I don't know if the child was trying to be funny. Child. Teenager. Yeah. Do you need more time there on box method? Okay. These ones can mess you up because they put a 2 out front of the whole thing. Here's what I suggest you do. You put a little box around the 2 and go, yeah, I know, multiply by 2. I'll get to that in a minute. I'll do my other multiplying, and then I'll multiply by 2 afterwards. So I'm telling you, most people find that the easiest way. Because if that 2 wasn't there, this is the exact same as the previous question. So all I'm going to do is do what I did on the last page. And then at the end, I'll multiply it by 2. Can't forget. Multiply it by 2. So here it comes. Again, this PowerPoint doesn't do it, but I'm going to do it. Ignore the 2 at first. I'm just doing this. So I'm just going 2 times 4x, which is 8x squared. You can write it underneath. The PowerPoint's going to do that in a minute, but I want to do it in order as we go. 2x times negative 3, negative 6x. 5 times 4x, 20x. And 5 times negative 3, negative 15. That's exactly what the PowerPoint's going to do. There it is. Do you see the 2 out front? I'm going to put it in a box again to go, yes, I have not forgot about the 2. Eventually, I got to multiply by the 2. But I'm not going to do that first because it might mess me up a little bit. I still collect up in the brackets, though. Negative 6x plus 20x is 14x. And now the last step. Multiply it all by 2. And we did this in a previous chapter where we just did the arrow. Much simpler here, just everything's getting multiplied by 2. Okay? So when there's a number out front, just ignore it until the end. Deal with it at the end. So that number out front doesn't have to cause us big problems. My brain tells me 2 more. If your brain's seizing up, if your hand's starting to shake because you can't resist touching your phone for 20 straight minutes, just hold tight. 2 more slides. Oh, okay. I thought you were doing the preemptive bathroom thing. I was going to shoot with my laser. Look. Look. Do you see? You have any questions there? Mr. Todd, can we do the same one with the box? I really like the box method. Okay, well, get ready. If you like the box method, then get ready for it. Or you can sneer at it while you write the box method the whole time. Sorry, I'll do one in a minute with box method. Oh, no, I want to do this box method right now. I'm leaving the PowerPoint. You don't have to write this, but I want you to see this with the box method, okay? Here it is with box method, okay? For those of you who love box method. What was the question again? It had a 2 out front. 2. And then what was it? 2x plus 5 and 4x minus 3. Here you go, box method people. Here's what you'll do. You'll make your big window box here. You'll put 2x and 5 across the top, and you'll put 4x and negative 3 along the side. Very visual. And then you just fill in each box. 8x squared, 20x, negative 6x, and negative 15. Okay? So can do with box. I'm not trying to say don't do with box. Questions there on box method? Okay, back to the PowerPoint. Was I there? I did that one. Now this one. Not this one. We did that one. Yes? This one. Oh, yeah?
He ran to the office, what?
Oh, yeah? Was it somebody you knew? Were you trying to get him in trouble?
Yeah.
I shouldn't laugh at that. That's not funny, but right.
Yeah, it's Peter Meal if you ever see it.
Who wants to help me with this? What am I going to do with the negative 2? Box it. Drop it into box and say, yep, I haven't forgotten about it. But for now, I'm just going to ignore it and I'll deal with it at the end. Totally allowed to do that, multiplied by negative 2 later. Then do FOIL. 21x squared minus 14x minus 3x plus 2. Everything gets multiplied by everything. If you're doing box, go ahead. Just switch over and do box. In fact, I'll do box over on the board here. Box people are doing this instead. They're like, no, 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 no. 7x minus 1, 3x minus 2, and they're getting the exact same things, but this makes them much less stressed. You see how they get the exact same thing? Oh, yeah, you were doing the other box. That's okay.
They left again, they ran that way. There's 3 of them this time.
Are they peeking in? Is that what's happening?
Yeah. They went to the left.
So many people out there. Should I stay right here? No, they'll catch me there. All right, I'll jump across.
You gotta like duck and then just pump up.
Always collect up those center terms.
Or Mr. Keller, go duck and then go through that door and then stare.
I don't know if that door works or not.
It used to when I had English in this school.
And it worked then? Yeah. And what did I forget to do? What's the last step here?
Times it by negative 2.
Times everything by negative 2. And if you need your calculator, oh, it's jam closed now. That'd be good. They're there and I jump out this door.
Why is your 2 doors right beside each other?
I suspect this used to be, maybe years ago, was like, there's a wall here, and this was like a storage room or office space for teachers or something like that. Way back when, there's a lot more office space for teachers and stuff like that, but no. Yeah. So then eventually they just dropped that wall, and then that door was like, well, waste of time. Oh. Do you have any questions about that? My brain tells me last one. Yes?
Yeah.
More time here? This one will cause you trouble. So I want you to put a star beside this one to look back at when there's a squared there, because when there's a squared there, you're going to have to write it out like this. So I'm going to put a nice big star there. You've got to write x minus 8 squared as x minus 8 times x minus 8. Thank you. I'm so excited. I'm going to send a picture of that to Mr. Jesjorski. Where was it? Where did they find it? Did they find it or did you find it? It was on a desk. I looked around down there. I couldn't find it. Look at how excited we are. This is how nerdy we are. Yo, it's the last one. The bottom, right there at the last page. It just says write blank in standard form. It doesn't say rewrite. You're going to have to put the rewrite. You're right. You're right. That's missing. There you go. Wow, that made my day. Thank you. I don't like to lose things, especially when they're other people's things. Look at. complete. Maybe he wants that picture too, does he?
I wish you had a noise.
Bloop. Thank you. All right, let's do this one together. X times X. X times X? X times X?
2x.
X to the power 2.
X to the power 2. X times negative 8? Negative 8x. Negative 8 times x? Negative 8x. And then negative 8 times negative 8, positive 64. Do you need your calculator? I don't know. I don't know. Maybe you can try them. See what you think about it before you write it down. And then collect up what you have in the middle there. Negative 8 subtract 8 is negative 16. X. What did I almost forget to do, though? What's the last thing? Multiply the negative 4 times everything in there. And there's the final answer. Now, you're at the stage where you might be like, hey, that was pretty good. I think I sort of understood that. Maybe I don't have to do this homework. Well, that's insane. If LeBron James showed up at school today, if Steph Curry showed up at school today, and you went down to the gym, he dribbled a couple times, made a three-pointer, swish, and went like this. Got it? You'd be like, yeah, I got it. Would you then head home and go, oh, I'm a great basketball player? No, you'd go and you'd practice it, wouldn't you? You go, okay, I've learned to do it. Now I can practice it. You've just watched me teach it. I'm not saying I'm the Steph Curry of mathematics. That's not what I'm saying. I'm saying once you've seen how to do it, you got to practice it. That's what the homework's for. Okay, stupid joke to finish. Sorry. Funny joke to end up with. This is apparently right from some students' actual test. They got given a test, and it said, expand a plus b to the n. And here's what they did. They just pulled it apart, expanded it. Is it funny? No. Probably the best we can do in class, though, for funny, right? Thanks. An actual knee slapper. Don't say that. I'm videoing.